welcome everyone to this session. Today we are going to be exploring a very interesting part. We have been looking at various content and various discussions of RAG applications using textual internal data, chunking and retrieval methods, semantic scoring, all that stuff. But think about it. Where does any company store its most important proprietary information? In databases, right? So it is very quintessential to understand how can we integrate structural data in SQL DBs. And there can be some structure and there can be some data in non-SQL DBs as well, no SQL DBs. But today we're going to look at the most important thing, which is how can we integrate the structured data in SQL DBs in our GenAI applications using yours truly, LangChain. First of all, I want to share an experience with you. So recently I was having a discussion with one of my friends who appeared in an interview for an AI engineer that was kind of focused around generative AI. And they were very interested in knowing about the skill sets around integrating structured data to a RAG application alongside textual data. And this is quite an unexplored section. People are exploring it, but it is not as popular as textual data, because textual data is kind of it comes naturally to large language models, but not structured data, not mathematical data. That's how it's perceived, right? But we have ways, we have some kind of techniques and some modules over in LangChain where we can do this, and we need to think about a lot of stuff when integrating SQL DBs. So first of all, the intuition part, I start all of my videos with intuition because it is very important to understand why are we learning this, why should we spend 30 minutes or 40 minutes with this lad to learn about this particular thing. Okay, so first of all, intuition. So first thing, whenever we are thinking of SQL DBs, SQL DBs, say SQL Server, MySQL, Oracle DB, or anything on the cloud, first thing that we think about is secure and scalable. We can apply all sorts of access control like row level security, table level security, all of that shit, alongside it being a very, very scalable, right? So that's one thing. Second, when we are working with textual data, we are retrieving on the basis of some semantic scoring, right? We are doing some sort of cosine similarity, which might capture the semantic or the context of the text, and it basically retrieves some top chunks from the textual data. But in case of SQL DB, the data which is stored there is absolutely accurate, 100%. And there are some scenarios where you want to get 100% accurate data. For example, if you want to get some information like who is the manager of X, you do not want a probabilistic answer over there. You want a single answer, an accurate answer that is probably stored somewhere in a SQL DB, because it is the most popular way of storing information by companies throughout the earth. Third is augmenting structured data. As I said, that most of the data stored by companies in the form of internal data is in structured format. It can be Excels, it can be SQL DBs. These are the most commonly used file formats in companies. So if we do not integrate SQL DBs to our RAG applications, to our GenAI application, we'll be missing out on a lot of important information, right? Fourth is a very important thing as analytical workload. So in case there is some chatbot we want to upgrade it to also accommodate analytical queries. Say that you have a table in which you've got some sales data, monthly sales data. What if someone wants to ask a question like, okay, my RAG chatbot, tell me what was the total sales for the year 2024? This needs an analytical query. What if it gets more complex? Something like what was the product category wise sales for the year 2024? Now we know that RAG applications nowadays can handle some sort of tabular data, but what if the data is really huge and the analytical workload is quite complex? We need SQL queries for that. So when we integrate SQL DB to our applications, we get this feature as well. So these are four common advantages that I could think of. There might be infinite more of them because this is really a hot topic. I must tell you that. And if you're appearing for jobs, interviews, and all that shit, you need to learn this. Okay, this is like the cornerstone of any GenAI application that's dealing with internal data. Cool. So there are two methods majorly in which we can integrate a SQL DB to LangChain. First is using chains, and the second is using agents. Whenever we are talking of agents, obviously we'll be going in the LangGraph direction because that's the most optimal way of working with agents in LangChain. So before we dive into this, I want to show you a DB that I'll be working with. Okay. So here I have the legendary SQL Server Management Studio opened over here, and I'll be working with this AdventureWorks 2019. I might want to zoom in a little bit maybe. So I'll be working with this particular database, and it has a lot of tables. So the reason I've chosen this particular database is because it is kind of augmenting a real life situation, right? In real world, every single database has a lot of tables, and we need to think about scaling it up, all that thing. So here we can see that there are different schemas like human resources, person, production, stuff like that. So I'll be working with this query. Let me show you what kind of information it's retrieving for us. So I'm getting the top 5 from production.product category table ordered by this. So this is the information that I'm getting. Let me zoom it a bit. Oh, not this. Just a second. Yeah, I think I can do it over here. Cool. So we can see that there are 4 product categories: bikes, components, clothing, accessories, all that. Okay. Now I want to query this database using my chatbot or using my LLM, and so that I can get all of this information in real time while talking to my application, talking to my chatbot. So in today's video we'll be looking at particularly this schema, the production schema, and let's see how it works. So as you can see, agents is for a story for another what if. I'll be covering this in a video later. Today let's talk about chains because it is kind of more on the basic side, more beginner friendly, and it is more low level. So it's beneficial to talk about chains first. Okay, first of all, let's see the workflow. It's looking very complex, but believe me, I have made it so to cover every single aspect of this. Okay, first of all, we have a chain which has 3 components: the create SQL query chain, execute query, and the LLM. Okay, this is my database that I showed you, the AdventureWorks database. And if you don't know about the database, by the way, you can just mention it in the comments and I will just guide you how to get that database, that sample database. It's very good for prototype projects and all that shit. Cool. So we have my database over here, which is a MS SQL Server DB, and I'm connecting to it using the SQL Alchemy engine, and this engine is powering this chain. Okay, so you can see that I have 3 chains over here. First we need to dive into the create SQL query chain. So before I kind of show you all of these arrows and all that things, let's get into the code first. Okay, I'll be sharing this notebook, by the way. And yeah, so first thing that we need to do is we need to arrange this connection we need to create a SQL database object so that our LangChain chain can access our DB through the SQL Alchemy engine. So first of all, I'm setting up a connection to the database. You can see all of these are the credentials for my database. It's a local database. This is the driver. You have to install it if you don't have it already, and then just add connection. Yes, okay. And then I'm using the SQL Alchemy library to create a SQL Alchemy engine. So SQL Alchemy engine is nothing but, it's basically speaking, it's kind of an interface that lets you interact with the SQL database using Python. Okay, you can do a lot of stuff, querying and all sorts of stuff using your Python scripts with the database. It's kind of an interface. So every single SQL Alchemy engine has a connection string. The connection string basically has all of these credentials. What is the driver you are using, what is the database name, what is the server name, all of these things, and we create this in connection string. Okay, you can see this connection string. It has driver, server, database, and connection, trusted connection, that is yes in my case. Simple. Then I create the Alchemy engine, simply create engine and with the connection string, and then I define a SQL database object for the production schema. For this schema. So the production schema will be containing all of these tables which have production.location, production.product, all of these things. Okay. The reason I'm using this, just the production DB, what if I do not mention a schema? If I do not mention a schema, it will by default take these three tables with the schema DBO. Okay. Or if I go for no schema, then it will consider all of the tables in this database. You might want to play around with it a little bit to understand more. Okay, so I have executed it already. I'm not executing it till right now because it takes around 4 to 5 minutes because of the volume of these tables. So the first step has been done. We have set up a connection to the database using the SQL Alchemy engine, and we have created this SQL database object. So we can access our database using this particular object. Let's see how we can do that. Checking out the connection and all things it can do for us. So this is the database object. Let's try to run this simple query. It's the same one that I was running over here, this particular one. So we can simply run this query over here using db.run. And you see we get these informations. I have selected only 2 columns over here. But obviously if I go for top 5 all, I'll get all of it. Okay, looks very shabby, so let's stick with the 2 columns. Okay, so we understand that okay, the connection has been set up, the SQL Alchemy engine is working, and we can access our database through our Python code over here. Cool, that's the first step. Now before we move ahead with the chain creation part, we also need to see some important features of this database object. This DB can give us the information about all of the tables that are present in the schema, which is production schema. So if I print db.getTableInfo, it will provide me with an information about all of the tables. Let's see. You see it's a pretty big set of information because it contains information for all of the tables in the production schema. So for every single table, first table is bill of materials, production.bill of materials. It has a create table code which basically contains all of the columns and the kind of definition that they hold, and sample rows, 3 rows from that particular table. So for every single table it has a create tables query and a sample 3 rows data. So this particular .get table info is very important because when we are using the create SQL query chain, in the background the LLM gets fed this particular information about the tables so that it can make a decision on how to write the SQL query. Okay, so you can see it's pretty comprehensive over here. All of this gets fed to the LLM in the prompt section. So all of this adds to the context length. Another thing that we should remember and keep in mind, all of this adds to the context length. Okay, cool. So this was how we can get the table info and how important it is. And by using db.getTableNames, you can get a list of all the tables from our schema. You can see all of these, so it has kind of a lot of tables. And we can also get the dialect of this database. Dialect is nothing but, if you have worked with databases, you know that a lot of databases, SQL databases, have a somewhat different kind of querying pattern or querying structure. Like Oracle DB's queries look different from MS SQL Server queries, and a little bit different from MS MySQL queries in some ways. Okay, so in db.dialect provides us what kind of dialect should we use to query this database. Another important information, because if the dialect is MS SQL, and if we use Oracle DB dialect, or if we use MySQL dialect, we might get an error at some point in time, because it's just a different database. Okay, so these are some important information that we can get from this database object. We need to know about these. Now let's start with the chain components. So first is the create SQL query chain. So create SQL query chain is kind of a module. It's kind of a class that is already present in the LangChain.chains module, and it is very important and kind of central to working with SQL DBs using LangChain. So let's come here. Okay, let's try to understand what it does. So it takes inputs an LLM, a DB in the form of a SQL DB object which we have already created, and a prompt. So I have instantiated the create SQL query chain with an LLM and a DB. Now you might be asking, where is the prompt? Well, if you do not provide it a prompt, it already has a default prompt to work with. The function of it is, it takes these things as input, and it provides a SQL query based on the user question. So here I have instantiated, right, instantiating the create SQL query chain. Here I have defined the LLM, and to get the response I'm providing these things. Okay, now what are these? So before I jump into this, let me just show you the default prompt being used by the create SQL query chain. This is the default prompt that it uses. Okay, I have it over here as well. Yeah, let's take a look at this. Given an input question, first create a syntactically correct dialect query to run. Now we can also define the dialect. You see, we can also provide the dialect to this prompt, but it is optional because we know that our database object already contains the dialect that we accessed using db.dialect. Okay, so if we want to generate it in a particular dialect, we want to explicitly state that, then we can use the dialect input parameter as well. Then look at the results of the query and return the answer, blah 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 blah. So basically what it is doing is, it is taking in a user question, a dialect which is optional, table info and top k, these four parameters, and feeding it to the LLM to generate a query fit for querying the database. Okay, now one thing, what is this table info parameter? Okay, only use the following tables, table info. Now we can provide create SQL query chain a list of tables from our schema, so that it can only access those tables and can create a query for those tables only. Very good from a security point of concern as well, and very good from a context length limiting mindset as well, because we know that if we do not provide any list of tables, then by default it will use all of the tables in the schema, which are all of these tables. Let me just show you again. It will use all of this information, the information around all of the tables in our schema, and feed all of this to the LLM's context, which is going to boost the context length, so more costly, and it also might, kind of exceed the context length limit in some cases. So this table info parameter is really important because it helps us to limit the tables that can be used by this chain. And then top k is limiting the results. So if, for example, if we want the query to generate only the top 5 rows of a particular table, then we can just provide the top k. If we have top k as 5, then it will limit the results to 5 while writing the query, which is it will straight up add something like, so here we have top 5. It will, if we have top k as 2, it will simply write a 2 over here and exit, so that when we execute it, we only get 2 rows. Okay, now is it compulsory to use this default prompt? No, we can have our customized prompt. I will show you how to do that as well right now. Okay, so basically it takes in inputs an LLM, a SQL database object, this prompt, and these parameters for this prompt. Out of these parameters, the dialect is optional, the table info is also optional. If we provide a table info, it will only generate a SQL query for those tables, from one of those tables or more if there is a join condition over there. And if we do not provide anything in the table info, then it will simply consider all of the tables in the schema in the SQL DB object. Top k is to limit the results, simple as that. Okay, now let's see what it does and how it does. Okay, so one cool thing about it is if I ask it something like how many product categories are there, and I've provided it this table, product category. Okay, now let's not provide it anything in table names to use. Okay, let's just provide it with just the question. So I'm invoking this chain, and I have a question, how many product categories are there? Now you see what it has to do now is, first of all, it has to identify which table to query to get this particular information, right? And right now it will be having all of this table info for all the tables in our schema as context, because we haven't provided any table info, anything in the table info parameter. So first it will decide which tables to query, and then it will generate a query based on that. Let's see what it does. The context length is big. Okay, it has come up with a error. You see the model's maximum context length is 8192 tokens, but we have a very big context with us. You see, I just told you about it. If you do not define anything in the table info thing, all of this will be provided as context, which might exceed the context limit as well. Let's try with model 4.0. Maybe 4.0 model will have a bigger context length, right? Let's see what it does. Yeah, you see we changed the model to GPT-4 Omni, and 4 Omni has a bigger context limit, so it worked. Select count product category ID as category count from production. Okay, now let's try to run it in our this thing. Let's see what it gives us. We got 4. That exactly answers our question, how many product categories are there. You see how beautiful this is, how important and how wonderful this is. Okay, but yeah, we face this challenge over here, and I want to work with GPT-4 or GPT 3.5 Turbo in my case, so I will just add a table info section over here where I'll be putting in a list, and the list will have the table that I want to use. This is using product category, right? Category. Yeah. Now I'm using GPT-4, not using GPT-4 for Omni. Again, it is telling me maximum content length is reached. Okay, let me see what's the issue now. Table info. Did I make any mistake in selecting that? Again, I'm getting a bad request error. Okay, there is some issue with this. Okay, just let me check. Product category, question, and table info. Let me just see over here. Maybe I made a mistake with the table names to use. Okay, this is not table info. This parameter is called as table names to use. My bad. Table names to use. Now let's see what happens. Yeah, now you see it provided as a SQL query, and now it did not encounter any kind of context length exceeding issue because we were using only one table over here. But what if the question is not fit for generating a query? What if I ask it something for which it cannot generate a query with the available table? So what if I ask it something like, how many countries are there in the world? Now I know that this particular data is not available in the database right now. Let's see what it does for that. I'm afraid I cannot answer your question using the available tables. Cool. So you might be thinking, why did not generate a generic answer? Because it is a chain that is instructed to generate a SQL query. That's it. It is not instructed to give any kind of responses as a fallback strategy. Okay, cool. Now we know how this part works. The create SQL query chain part. We provide it with some inputs, we get some output, and the output is a SQL query. Now I was telling you how can we change the default prompt that it is using in the backend. So this is the prompt that it is using. You can access this prompt using this module over here. I have printed it over here. This is the prompt that it is using currently in the backend. But if I want to change it, here I have created a new prompt. The prompt is kind of the same. Your helpful assistant tasked with generating plain SQL queries based on questions. This is the prompt which I have created. You can check it out when I provided the notebook. And then if I want to use this prompt instead of the default prompt, I just provide this prompt as an input while invoking the SQL query chain. Okay, let's see what it happens. Again the same question. Yeah, it is generating the SQL query, and this time it is using this particular prompt and not the default one. Okay, so that's how you can use your kind of own prompt if you have a custom use case or those kind of things. Okay, now once the create SQL query chain generates the SQL query, we need to execute the SQL query, right, to get the answers from the database. So we have the execute query part component of the chain. Its job is to take the SQL query generated by the create SQL query chain as an input and use that SQL query to run a query on the database and get results out of it. Okay, now how does it run the query? I mean, when it gets a query, how can we run the query? We run the query using this connection, using this Alchemy engine connection to the database. Now let's create this component. So we have this class from the LangChain module again. So LangChain helps us a lot in a lot of things, right? The query SQL database tool. As you can see that this is a tool, so it can also be binded with LLMs. It can also be used in LangGraph workflows as a tool node. All that shit holds true for this. Okay, So simple, it's a tool, it takes an input and gives an output. So here we have the execute query tool. We instantiate this object, and the input which it takes is the DB, the SQL DB object, to which we want to query. Now let's just comment this out for a while and check how it works. Okay, so let me just go and execute query dot invoke, and let's provide it with a query. Let's just provide it with this query. Okay, let's see what it does. You see, it provided me with the answer. The answer was 4. It provided me with the answer. What if the answer is in a structured format? It is not a one-word answer. So let's just provide it with this query that we got earlier. Where is it? Let's just generate another query using the query chain. List the product categories. Let's see what it does now. Okay, it got us a new query that is supposed to provide us the list of the product categories. We invoke the execute query object with that now. See what happens. Cool, we got the list: accessories, bikes, clothing, components. What if I run this over here? Let's check it, double check. Yes, we have got 4 categories: accessories, bikes, clothing, and components. Cool. So you see how it works. It's basically just querying our database using, again, this connection, super important, SQL Alchemy engine. So we use this in a small chain over here. We have created a chain that has only 2 components right now: the writer query and the execute query. The writer query is nothing but the create SQL query, and we are invoking it with a user question and table names to use. Okay. So let's see the response of the chain now. Same response. Cool. Now what if I ask it some other question from the product category? Let's ask it how many categories in product exist. So it is kind of a more complex form of the same question that we were asking earlier. Let's see what it does. Yeah, 4. Cool. Now we see that this particular component's job is to execute the query created by the query writer or the SQL query chain, this part. Now this particular information is not very good for providing to the user, right? We need to have the response in a natural language form to make it very understanding and to make it very naturally occurring to the user. So instead of an answer to the question how many categories in product exist, instead of the answer being simply 4 in the form of a tuple and a list, whatever, the answer should be something like there are 4 product categories, something like that, right? So for that we need an LLM. This LLM's job is nothing, but it takes in all the context. By all the context, I mean the initial question the user asked, the SQL query that was used to answer that question, and the query response that we got by querying the database. And in return, we demand a natural language answer from the LLM. Why are we providing all of this context? To make the answer more relevant, so that it knows what all things have happened. Now what should I answer? Let's see it in action. Answer generator. So there is a prompt, answer prompt. Given the following user question, corresponding SQL query and SQL result, answer the user question. We provided with the initial user question, the SQL query generated by the create SQL query chain, and the SQL result that we got from the execute query object. So let's see it in action. I'll be explaining this logic in a little while. Let's see it in action first. So we have created a chain. The chain is basically assigning the question to the create SQL query chain, which is a writer query over here, then to the execute query, then to the answer prompt, then to the LLM, and then we are parsing the output. Let's see how it works. Again, I'm asking it the same question: list all the product categories. Now I do not demand an answer which looks like this. I demand a natural language answer, right? Let's see what happens. Running. You see, now the answer looks much better. The product categories are accessories, bikes, clothing, and components. Cool. If I ask it something like this, how many categories in product exist? If I ask this question to it, there are 4 product categories. Cool. So you see, this completes the entire chain. We took a user question, created a SQL query, executed that query, got the response, and again fed it back to the LLM to get a natural language response. Now let me explain this logic a little bit. If you want sessions on LECL, LangChain expression language, this is what it is. Just nudge me on the comment section. I'll create a video on that. Right now I'm assuming that you have some knowledge about LECL. So what it's doing is, first of all, it is assigning the key query the value which is obtained from the writer query. And the writer query is nothing but the SQL query chain, this thing. So this thing I'm referring to as, just let me come here, writer query. Okay, let me just black and okay, this is the writer query, this is the execute query, and this is the answer generation, whatever. Okay, so first of all, what's happening is, when I'm invoking it, I have this dictionary. I'm basically invoking this chain with this dictionary. What this thing is doing, it is adding another element or another key to this dictionary called as query, and the value that this key holds is provided by the output of the writer query. So it is the SQL query. I'm just writing it in the form of a string. Okay, now after it has assigned the output of the writer query to this query key, now it is assigning some value to the result key. Now it is creating another key called as result key, and to this key it is assigning the value that is obtained by the execute query. So it is assigning the queried information, or I should write the information from DB. So up until this point, this is how the dictionary looks like. Then it passes all of this information to the answer prompt. The question comes from the question key, the query comes from the query key, the result comes from the result key, and then it goes to the LLM, and then we get the answer. So this is just a quick little way of how this chain is working. Okay, now that we have explored this, to add on top of this, I would like you to show the LangSmith trace of this thing. Let's see if I'm getting it here. Just a second. Yeah, I think I have it here. Let's see now. I'll be sharing this link as well to the LangSmith trace so that you can have a deeper look into what was going on in this chain. We started off with this question. You can see the dictionary over here, question and table names to use. Then we assigned another key as query. This query, as I told you over here, contains the SQL query generated by the writer query, which is this. Then we assigned another key to this dictionary, which is result. Result is obtained by executing this query, and then we are feeding it all to the LLM, and we get this information. You can again see the prompt template being formed over here, which is this. Where is it? Yeah, which is this, right? Anyways, yeah. So this is the final response that we get. So I'll be just also including this particular link to this trace in the video's description as well. So now that we got a hang of how the chains part works while working with a SQL DB, in the next video probably we'll be looking at how do we integrate a SQL DB using agentic workflows. And by the way, uh, just a little personal talk. I was also thinking of creating some content around data science topics like recommendation systems, like clustering and all those things, because I know that there is content out there for all those things, but still, people don't get the hang of the entire concept. So I was thinking if I can create those kind of content for you. If you think that I should do that, just mention it in the comments and I'll get going. Anyways, thanks for learning. I hope you learned something. And from an interview perspective, this is very important that you deep dive into it, play around with the notebook. And yeah, bye bye. Thanks for watching.